Hello, let's move to the last example for this topic on introduction to basic concepts of ordinary differential equations. Example number 9, linear combination of solutions. So in this example, I will show that if an ordinary differential equation, especially second or higher order differential equations, have two or more solutions, then the linear combination of those solutions will also be the solution of those equations. So this type of observation will be very useful later on in the solution of the second order ordinary differential equations. Okay, so let's take the example. Okay, so verify that the function x is equal to c1 cosine of 40 and x is equal to c2 sine of 40, where c1 and c2 are arbitrary constants or parameters, are both solutions of the linear differential equations x double prime plus 16x. So we need to verify it. Also verify that the linear combination of the two solutions, these two solutions are given, is also a solution of the differential equation. That means if we sum up these two solutions and then try to verify with these sum up of these solutions, then that will be also a solution of this differential equation. Remember that there is some change in this example. Instead of taking x as a dependent variable and y as the instead of taking x as the independent variable and y as the dependent variable, which is normally the case for most of the time, I am taking over here as t, which is normally represented by which normally represents the time. I'm taking t as the independent variable and x as the dependent variable. So, well, everything is possible. Okay. So let's verify that these are the solutions. So we can quickly see that in this differential equation we need the x term and the second derivative of x. So if I have this x as equal to c1 cosine of 40, which is the given solution, its first derivative will be minus 4, because minus will come from the derivative of cosine. The derivative of cosine is minus sine. Okay, so minus 4c sine 4t, and that 4 has come from the chain rule. Okay, if you apply the chain rule, then 40 derivative of 40 will be 4. So similarly, the second derivative will then be, again 4 will come out, so it will become 16, and the derivative of sine is cosine. So there is no change of this negative sign, because cosine is minus sine, sine is cosine. Okay, so minus 16c1 cosine of 40. So in this case, what we have to do is we have to substitute x prime and x into this equation, and then we can very easily see that it was minus 16c cosine 40, and then it was cosine t. Okay, so minus plus, so 0 is equal to 0. We can verify that this is the solution. Similarly, for the other solution, which was in terms of the sine of 40, we can verify it. So from sine, it will be, first derivative will be cosine, okay, and the second derivative will be minus sine. Okay, I did not show the first derivative, so you can take this derivative even in your head as well. Of course, you may be very used to of taking these signs as well, but remember that I think it's always better to show all steps whenever you submit your assignments and exams. Okay, so I think sometimes it's not that good to do everything in your head and then just write the final answer. You should make a habit of providing all the steps for your solutions whenever you are doing your assignments and exams. Okay, so in this case, actually I have skipped it. I should not have done it, but anyway, since it was quite simple, that's why I did it here. Okay, anyway, it's minus 16c sine 4t, and just input these values into this equation, and then you can see that it is minus, this is plus, 0 is equal to 0. So individually we have found that these two equations satisfy this differential equation. But how about their combination, a linear combination? So the linear combination will be that we can just add these two values together. Okay, that will be a linear combination, or maybe subtract it, but okay, adding and subtracting is basically the same thing. But of course you should not multiply it. Okay, for example, multiply this solution with that solution and then you are trying to verify it. No, this is not the multiplication, is not a linear combination. Okay, linear combination is only the addition, okay, with some multiplication of some constant, and then so constants are already there, so we are just adding these two values. So in this case, x prime will be this, cosine change to sine, and from plus to minus over here, and then 4 will come out, sine change to cosine, and then 4 will come out. Okay, plus will remain plus. Okay, and the second derivative will be, so from sine it will change to cosine. Okay, there will be no change of sine from minus will remain minus. Cosine will change to sine, and then 4 will come out, will multiply with 4, it will become 16 into in these two terms, and sine will change from plus to minus, because from cosine it is minus sine, the derivative. Now you can just we can just input this value x double prime into this differential equation, input these values, and then here it is the value of the x double prime, here it is the value of 16 times the x. Okay, and you can see that 16 you can cancel out to make it simplified, so it will be this, and then you can see that this term is cancelling out with this term, and then minus c2 sine 4t is cancelling out with plus c2 sine 4t. So in the end it is 0 is equal to 0. QED. QED is some, I don't know, is something, some Latin. You can find what exactly in Latin it means, but it's the same meaning as hence proved. So since there was not enough space, I just used this abbreviation over here. Okay. So in the end, I can ask you that what lesson you have learned from this example. Okay. So it's very important to remember those lessons or rules which you learn from each of these examples or topics. Okay, so with that, I think I have completed this tutorial. So I will continue preparing you more tutorials with the examples, and I hope it will be useful for you. Thank you.